Hi, this is King of Review. If there is only one solution for the following system of equations, state the conditions for constant A. So we have our system of equations here. These are equations for lines. So let's think about this. If we solve for x and y, that represents the intersection point for these two lines. Now we're told that there's only one solution. So this means that the lines only intersect at one point. Now if we have two equations that are in the form ax plus by equals e and cx plus dy equals f, then we can set up a matrix equation that represents this system. The first matrix is going to be the coefficient matrix. So we're going to take the coefficients of the x and y terms, a, b, c, and d. We'll multiply this by our variables x and y, and this is going to equal a matrix with our constants, e and f. Now let's look at the determinant of our coefficient matrix. To find the determinant, you multiply the entries in the main diagonal, a times d, and then subtract the entries in the other diagonal, c times b. Now when we do not have any solution for the system, we would set this equal to 0. But in this case, we're told that there is a solution. There's one solution. So we know that this is not equal to 0. So now let's set up our matrix equation for our system. Now you can see here that we do not have a constant on the right-hand side. So we need to change this. The first equation here, we're going to subtract this ax on both sides. And this leaves us with 5 minus a times x plus 3y equals 0. And now for our next equation, 8x minus ay equals negative 3y. We're going to add a 3y on both sides. So this leaves us with 8x plus 3 minus a times y equals 0. So we have our two equations here, and they are in this format. So now we can set up our matrix equation. Starting with the coefficient matrix, these are the coefficients. So we have 5 minus a and 3, 8, and 3 minus a. And then we multiply this by the variable matrix, so x and y, and this is equal to our coefficient, or our constant matrix. And these are the constants. These are the e and f values, 0 and 0. So now let's figure out what our determinant is. We're going to multiply these two entries together. So we have 5 minus a times 3 minus a. And now we'll subtract the product of these two entries, 8 times 3. And again, if there is only one solution, then we know that this determinant here is not equal to 0. Now, a side note here, what does this represent? Some matrices do not have an inverse, and you can tell if the matrix has an inverse by evaluating its determinant. If the determinant equals 0, then it does not have an inverse. So if this were equal to 0, then we would know it would not have an inverse. But because it's being set to not equal 0 here, we know that there is only one solution here. So the first step here is to FOIL this. When we FOIL this, we get 5 times 3, which is 15. 5 times negative a is negative 5a. Negative a times 3 is negative 3a. And negative a times negative a is a squared. And then we have minus 8 times 3, so minus 24. And this is not equal to 0. Now let's combine like terms here. So we have a squared minus 8a minus 9, and this is not equal to 0. And now let's factor. A squared, well, that's a times a. And now we're looking for two numbers whose product is negative 9 and sum is negative 8. Well, 1 and negative 9 would work, so we have plus 1 and negative 9 here. So now, if we think about the zero product property, if we have two numbers, let's call them a and b, and they're equal to 0, then we know that either a or b must be equal to 0 because any number times 0 equals 0. So a times 0 could equal 0, or 0 times b could equal 0. In this case, we want to know what does not equal 0. So we can apply the same principle here, but we know that we're looking for one that does not equal 0. So we have a plus 1 does not equal 0, and a minus 9 does not equal 0. So here we're going to subtract a 1 on both sides, so a cannot equal negative 1. And here we're going to add a 9 on both sides. We have a does not equal 9. So a cannot equal negative 1 or 9. Letter A is correct. Thanks for watching.